If you carefully place some crystals of a substance called potassium permanganate at the bottom of a beaker of water, it starts to dissolve and gives the water a dark purple colour. And thanks to this purple colouring or staining of the water, you can see that once it starts being heated, the water begins to rise. So the water closest to the heat source at the bottom of the beaker is heating up first, but as it is heated, it starts to move upwards. Now this is essentially allowing us to see how heat is moved through the water. To explain why this happens, there are three concepts you need to understand. 1. How particles in liquids and gases move. 2. What density is. And 3. What happens to matter when it's heated. Particles in liquids and gases are free to move. Particles in liquids are close together and are moving around slowly, and particles in gases are spread apart and moving around very fast. Because of this, both liquids and gases are fluid. They are able to flow. The particles are not in a fixed position. Density is a way of describing how much mass something has for its size, or how much stuff there is in an amount of space. A material that's less dense than water will float, and a material that's more dense than water will sink. So this happens with liquids, but also with gases. So a balloon filled with helium will float because it's less dense than the surrounding air. So linking this back to the particle model, these three objects have the same volume, but there are more particles in the high density object than there are in the medium and low density objects. Their particles are spread further apart. We know that when an object is heated, its particles vibrate faster and push each other apart. You can see this in the animation, that at a low temperature on the left, the particles are closer together than when they are at a higher temperature on the right. So when an object is heated, its mass stays the same, but its volume increases. Therefore, its density decreases. Let's apply these concepts to the water we observed at the start of the lesson. The water directly above the heat source gains thermal energy. This causes these particles to vibrate more rapidly and take up more space, thus decreasing in density. And we know that lower density substances float, so the hot water rises upwards. Cold, dense water at the bottom of the beaker moves in to fill the space left by the rising warm water. Then, as the warm water moves away from the heat source, it cools slightly, transferring some of its thermal energy to other water molecules. As it cools and increases in density, it starts to sink back down. This quickly forms a cycle of rising warm water and sinking cool water. And when thermal energy moves through a substance in this way, we call it heating by convection. And we call the circulation, or the movement of the particles, a convection current. Heating by convection can only occur in substances that are fluid, that is, liquids and gases, because for convection currents to form, the particles must be able to move. Besides water in a beaker, where else does heating by convection occur? Air above a heater rises and then forms a convection current which circulates heat around a room. During the day, the sun heats up the land quicker than water. This causes warm air to rise over the land, while cooler air sinks over the water, leading to a convection current and cool sea breezes near the shore. And this cycle actually reverses in the evening when the sun goes down, because the land cools down quickly, whereas water retains its temperature.